Welcome dear students, welcome back to physics class. Okay, so last class we had discussed some numericals, important numericals from the lesson unit and measurements. Now some more lessons we are going to discuss. This is a question from our book example. Okay, and this question is very important question. So same like models you may have going to face in JEE exams. So carefully look into the questions. Two resistors, already we know resistors. In our 10th standard we have studied, which regulate the flow of currents, which determine the flow of current. A resistor is a component that regulates the flow of electrons through any instruments. Okay, so this is a symbol of resistor. This two resistors are given. This is a resistor R1. Similarly, another one resistor is R2. So two resistors are given. The first resistance value is 100 ohm plus or minus 3 ohm. So this is the measurement R1. This is the error. So this is R1, this is delta R1. Similarly, the second resistance has the resistance. The second resistor has the resistance 200 ohm plus or minus 4 ohm. So how these two resistors are connected? These two resistors are connected first in series. Okay. In first case, the two resistors are connected in series. So R1 and R2 are connected in series and then in parallel. In second case, it was connected in parallel. In second case, the first resistor R1 is connected with the second resistance in parallel. Okay, the two resistors again it is connected in parallel. Find the equivalent resistance of the series combination and parallel combination. So we should find the total circuit resistance when they are connected in series and when they are connected in parallel. Use the following relations. They given the relation also directly because you may forget from your 10th standard. So directly they given the relations. In series combinations, the equivalent resistance is sum of the individual resistance. Similarly, in parallel combinations, this is a relation we are going to use. So 1 by R dash is equal to 1 by R1 plus 1 by R2. These are the relations we are going to use. Okay. So in the first case, in series combination, so this is in series combination, directly we can add the resistance. The total circuit resistance is the sum of individual resistance, no? So we need to add the value. So 100 ohm plus or minus 3 ohm plus 200 ohm plus or minus 4 ohm. So we need to add this resistance value. That is R1 plus R2, then plus delta R1, yes, this is plus or minus, delta R1 plus delta R2, delta R2. What is R1 and R2? It is 100 plus 200, that becomes 300 ohm, then plus or minus 3 plus 4, it is 7. So this is the total circuit resistance when they are connected in series combinations. So the one setup is over. Okay, series combination is over. Next we are moving to parallel combinations. Because in series combination, the total circuit resistance will be greater than the greatest of individual value. If in the two resistors greatest value 200, அது கூட total circuit resistance அதிகமா தான் வரணும். புரிஞ்சுதுங்களா? But in parallel combinations, the total circuit resistance will be less than the least of individual. So இப்போ இந்த ரெண்டு ரெசிஸ்டன்ஸ்லயும் least value ன்னு பார்த்தோம்னா நமக்கு இதுதான் least value. 200 விட 100 is less. So total circuit resistance will be less than the least of individual resistance. So இதுக்கு இந்த relation use பண்ணி calculate பண்ண சொல்லிருக்காங்க. So first we will find this value. So in this combination using cross multiplication, what will get? R1 plus R2 divided by R1 R2. But take reciprocal on both sides. By taking reciprocal on both sides, R dash is equal to R1 R2 divided by R1 plus R2. So multiply the value. What is the resistance R1? R1 is 100 ohm, R2 is 200 ohm. So multiply the value directly. 100 into 200 ohm divided by summing these two resistance value. 100 plus 200. Okay. Then finally we have it is 20,000 ohm divided by 300 ohm. After the simplification, this 2 zeros cancel away. Then divide it. 200 divided by 3. Okay, using 3 table, 6 3s are 18, remaining to 20. Again 6 3s are 18, remaining to 20. it goes on. Okay, by round of digits we can say the resistance value is 66.7 ohm. This is the resistance value. So this value is less than the least. What is the least value in these two resistors? Among these two resistance, 100 is less value, but the total circuit resistance will be less than the least value. Okay, so first relation is over. Now moving to the second relation. In the relation we use panni error resistance calculate பண்ணுங்கன்னு சொல்லிருக்காங்க. So using this relations, I'll rub this side. So using the relations, what is the next relation is given? Delta R dash by R dash squared is equal to delta R1 by R1 square plus delta R2 by R2 square. Okay, but we need to find the error. So the denominator value transferred to the right hand side, it gets multiplied. Therefore delta R dash is equal to, this R dash square is common for both the terms. So R dash square is common for both the terms, delta R1 by R1 square plus delta R2 by R2 square. Okay, then further you can rearrange it. Delta R dash is equal to R dash square divided by R1 square into delta R1 plus R dash square divided by R2 square into delta R2. Okay, now substitute all the given value. What is the R dash? Already we found the R dash. The total circuit resistance in parallel combination will be less than the least. Okay, so substitute the value. It is 66.7 square divided by, what is the R1 value? The R1 value is 100, so 100 square. So commonly you can take the square outside. Into delta R1. What is the delta R1? 3 plus 66.7 square divided by 200 square into, what is the R2 value? 4 ohm. Okay. Then similarly you can take the square commonly outside. Then after the simplification, finally you have the resistance value which is 1.8. So after the simplification, the resistance value is 1.8 ohm. Therefore error in the combination is 1.8 ohm. Okay. Therefore our final result is the final result of R dash. So with the R dash, therefore R dash will be 66.7 ohm plus or minus 1.8 ohm. So this is our final result. Okay, it's a very simple method. Already what method we used in our 10th standard, the same procedure we are going to follow. Two resistors are given, R1 and R2. Two resistors are given and the two resistors are connected in different combinations. In the first combination, it is connected in series. Second combination, it was connected in parallel. In series, we need to use this relation, and parallel, we have to follow this relation. In series combination, we have found the solution directly, because in series combination, the total circuit resistance will be greater than the greatest of individual value. Then in parallel, the total circuit resistance will be less than the least of individual value. Kuduthirukka rendu resistorla 100 ohm is less, so the total circuit resistance is 66.7, which is less than 100 ohm. Also, we need to use this relation, which means we need to find the error. Okay, so to find the error, we are rearrange this steps. This is a given relation. The denominator error value you are transferred to the right hand side, then it is commonly multiplied. Then the squares you take it outside, then substitute the given values. Then after the simplification, the error is 1.8. Okay, so in parallel combinations, the total circuit resistance, this much error may be added or subtracted. Okay, then moving to next question. Next question, question number 2. Look at the question. A screw gauge. Already we know a screw gauge is the instrument used to measure very small dimension, particularly thickness of a wire, like diameter of a wire. Similarly, here also a screw gauge gives the following reading when used to measure the diameter of wire, like a copper wire or any metallic wire. We can easily measure the diameter because the shape of the wire is cylinder. So in the cylindrical wire, easily we can measure the diameter. Okay. They given the main scale reading. The main scale reading of the screw gauge is 0 millimeter, and the circular head scale reading is 52 divisions. They given main scale reading and circular scale reading. Given that 1 millimeter on the main scale corresponds to 100 divisions of the circular head scale. So the number of divisions on the circular head scale division is 100. Look at the diagram. A screw gauge is U-shaped metallic frame. A screw gauge is a U-shaped metallic frame. One end of the frame is connected to head scale. Then this U-shaped metallic frame, one side a stud is fixed. This is a stud S1 is fixed on the one side. Then this is called a pitch scale. In the pitch scale, the readings are like ordinary scale. It is graduated in millimeters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So likewise, the readings are marked on this pitch scale. So this is called pitch scale reading. On this pitch scale, the grooves are cut the inner surface. You know grooves, mara irukulla nama bottle tight pandradhukku release pandradhukku. So on the cylindrical pitch scale, the grooves are cut the inner surface through which a sleeve is passing through it. This sleeve have a head scale. This head scale marked in divisions. Start from 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes on up to 95, 96, 97, 98, 99. So number of division on this head scale is 100. And this is a sleeve. This sleeve have further arranged arrangement. This arranged arrangement to avoid the overscrew of the screw gauge. When this sleeve head passes to this pitch scale reading, and since the grooves that helps to move inner side of the pitch scale reading, this grooves side have one movable stud. So this is a stud S2. This stud is movable. While you rotate this arrangement, the screws will move to and fro. Anyway, the arbor should be placed between the two studs. Okay, and this is U-shaped line. This is pitch scale reading. This is a head scale, and this is a sleeve, and this is a ratchet arrangement as a safety device to avoid overscrew. Now look at the questions. They given the main scale reading. Okay, so the pitch scale only we can say as a main scale reading. It is also called as a main scale reading. It is in 0 millimeter, and the circular head scale have how many divisions? From 0 to 99. So total divisions are 100. Okay, on the 100 then we multi 0 and start பண்ணுவோம். So number of division on the head scale is 100. But the circular head scale division is 52 divisions. Now circular head scale have 52 divisions. இப்போ இந்த இடத்துல நமக்கு காமிக்கிறது வந்து இந்த கோஇன்சிடென்ஸ் பாத்தீங்கன்னா 52. இப்போ क्वेश्चनல என்ன கேட்டிருக்காங்கன்னா you need to find the diameter of the given wire. So the wire is placed between the two studs. Then we need to find the diameter. Okay. So first we find the least count. What is the least count? The least count of the screw gauge is a ratio to the pitch to number of divisions on head scale. Number of head scale divisions. But what is the pitch scale? Pitch scale is nothing but if you give one full rotation, the sleeve head moves one division on main scale. Can you able to understand? நீ இந்த circular head scale ஒரு clockwise இல்ல ஒரு full 360 rotate பண்றப்போ for every one full rotation this arrangement moves 1 millimeter. Then second rotation 2 millimeter, third rotation 3 millimeter, fourth rotation 5 millimeter. If you give the pitch, but pitch is what is the pitch? Distance travel when number of rotation made. Pitch is nothing but distance travel when the number of rotation given. If you give one rotation, it moves 1 millimeter. So the pitch value is 1 millimeter. Now substitute. Least count is the ratio between pitch by number of division. Now pitch value we found. If you give one rotation, circular head scale rotations, it moves 1 millimeter. Then The number of rotation also, then we found the value. Number of edge scale divisions. How many divisions on the edge scale? They mentioned it is correspond to 100 divisions. Therefore, 1 by 100 is equal to 0.01 millimeter, or in centimeter, what is the value? In centimeters, 0.001 centimeter. Yes. So this is the least count of screw gauge. Okay. We found the value in both millimeter and centimeter. Normally we stop up to millimeter itself. So 0.01 millimeter is the least count of screw gauge. Now generally how to find the least count of screw gauge? We got it. Okay. Now from our experiment, we need to find the diameter of the wire. No. So diameter of the wire have a formula. Diameter of the wire is main scale reading plus circular scale reading into least count. Circular scale reading into least count. What is the main scale reading? It is 0 millimeter, and circular scale reading, it is 52 divisions. And what is the least count of the screw gauge? It is 0.01 millimeter. Therefore, 0 millimeter plus, multiplying this value, it is 0.52, not 52, 0.52. Yes. Multiplying this value, it is 0.52. Yes. 0.52 millimeter. Then finally 0.52 millimeter, or in centimeter, it is 0.052 centimeter. Hence we found the diameter of the wire, the diameter of the given wire from main scale reading and the circular scale reading. Okay, main scale reading la வந்து இப்ப நமக்கு எப்படி காமிச்சிருக்கோம்னா, இப்ப நம்ம क्वेश्चनல கொடுத்திருக்கிறது நமக்கு இப்படி இருக்கு. இது ஜெனரல் ஆஃப் ஸ்க்ரூ கேஜோட அரேஞ்ச்மென்ட், பட் நம்ம கொடுத்த டேட்டாஸ் பிரகாரம் பார்க்க போறோம். Zero, 50, 45, 55. இப்படி தான் ரீடிங்ஸ் இருக்கு. கரெக்ட்டுங்களா? So this is the main scale reading. It is 0 millimeter, and coincidence is 52, because see, to the reference line of the main scale reading, head scale oda எந்த division coincide ஆயிருக்குன்னா 52 division coincide ஆயிருக்கு. இது क्वेश्चनல கொடுத்திருக்க பிரகாரம். But what is the diameter formula of the thin wire using screw gauge? The diameter of the wire is the sum of the main scale reading and circular scale reading into least count. But main scale reading is given 0 millimeter. So you look at that, and stud is placed. இப்போ நம்ம என்ன பண்ணிருக்கோம், wire இப்படி place பண்ணிருக்கோம். This is a stud S1. Here cylindrical wire is held, and this is movable stud. This is a movable stud S2. Now this reading only is given here. Okay, according to this reading, how to find the diameter? Diameter is the sum of main scale reading and the product of circular scale reading into least count. Main scale reading is 0 millimeter. Circular scale reading is 52 divisions, because out of 100, the 52, see 45, 46, 47, 48, 49, 50. Then 51, 52. With the reference of the main scale, in the division coincidence, that is the head scale coincidence. The head scale coincidence only they given as a circular scale divisions, 52. Then we can get the diameter. So the thickness of the wire in both millimeter and centimeter is given. Moving to next question. Question number 3. Look at the question. This is from Coulomb's law. You need not to worry about Coulomb's law. You are going to learn in your 12th standard first lesson. Okay, it is nothing but force between 2 point charges. Okay. Let epsilon naught that denotes the dimensional formula of permittivity in vacuum, that is empty space. If m is mass, L is length, T is time, and A is electric current. They mentioned the dimensions of 4 quantities: length, mass, time, and electric current. For length it is L, For mass it is M, for time it is C, and for electric current it is A, ampere. Then find the dimensional formula of epsilon naught. We need to find the dimensional formula of epsilon naught. This epsilon naught means it is permittivity in vacuum, permittivity of vacuum or empty space. Use Coulomb's law. They given the formula. Look at the solution. So Coulomb's law gives a force between the 2 point charges. Let 2 point charges Q1 and Q2 are separated by a distance r in a vacuum. Then force between the two charges is directly proportional to product of the charges, but the force is inversely proportional to square of distance between them. By recombining this both, force is proportional to product of the charges, but inversely proportional to square of distance between them. Whenever the proportional become equal, here we get one constant. Here K is the proportionality constant. So the proportional become equal, we get one constant K. So K into Q1 Q2 by R square. Whereas the K value is found, it is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught into Q1 Q2 by R square. Therefore F is equal to 1 by 4 by epsilon naught into Q1 Q2 by R square. Whereas epsilon naught is the permittivity in free space. So this epsilon naught value to be determined. So how to determine this epsilon naught? You rearrange this force and the epsilon naught alone, you rearrange. So we'll get epsilon naught is equal to Q1 Q2 in numerator, whereas in denominator it is 4 pi F into R square. This epsilon naught only we need to find dimensional formula. No. So first you set the unit of this terms. From the unit you can easily frame the dimensional formula. So set the unit. It is a charge, no? So charge is nothing but rate of flow of charge is nothing but current. Therefore charge is equal to current into time. So I into T, again I into T divided by 4 pi constants. We cannot set unit, so we leave it. For force it is Newton, and for distance square, so it is meter square. Then again epsilon naught is equal to current into current. What is the unit of current? Ampere. So ampere into ampere, ampere square. Time into time, second square. Okay. So ampere square into second square. For time they given it is C, and ampere also we have got it. So ampere square into C. Current into current, time into time, divided by Newton. No, Newton is the unit of force. So what is the dimension? It is mass into acceleration. For force is the product of mass into acceleration, and for mass it is m. Acceleration meter per second square, so LT power minus 2 into meter square. What is the meter square? L square. Then ampere square time square divided by mass. This L power 1 into L square become L cube, and T power minus 2. The denominator you change to numerator, then we'll have the mass denominator become numerator, the power is 1 and it goes to numerator, this is m power minus 1. Then L cube denominator become numerator, it is minus. Then here time square is there, the denominator minus 2 goes to numerator, it becomes again time square. So time square into time square become time power 4. Then ampere square. So we said the dimensional formula. Therefore dimensional formula of the permittivity of vacuum is, therefore the dimensional formula of permittivity in vacuum is m power minus 1, L power minus 3, T power 4, current ampere square. Okay. So this is the dimensional formula of this three things. Next question number 4. Look at the question. The dimensional formula of magnetic field strength is mass, length, time, coulomb. It is given as the magnetic force is a product of magnetic field strength, charge and velocity. Okay, the magnetic Lorentz force is equal to the product of magnetic field strength, charge and velocity. It is given. But what we need to find? We need to find the dimensional formula of magnetic field strength. Okay, therefore given magnetic force is the product of magnetic field strength, charge and velocity. Okay, we need to find the magnetic field strength, no? So magnetic field strength is the ratio to force by charge into velocity, because F is equal to QVB. Okay, as we know the dimensional formula of the force, charge and velocity. So substitute the dimensional formula of force, charge and velocity in above equation. Then we have the magnetic field strength is equal to force. Force is a product of mass and acceleration divided by charge. Charge is a product of current and time, because I is equal to Q by T, Q is equal to IT. And velocity is the rate of change of distance, not distance, displacement. So displacement by time. So this time and this time is cancelled. Then we have, now you substitute the dimensional formula. From the unit I am going to substitute the dimensional formula. So from the unit mass m and acceleration mlt power minus 2 divided by current into displacement. Okay, current is ampere and displacement it is meter, so L. So both get cancelled away. Then finally we have, yes, finally what we have, mlt power minus 2, current it is not ampere, current into second, no, yes, there are some changes. I is equal to Q by T. So Q is equal to I into T. So SI unit of current is ampere, ampere into second, and the velocity is meter per second. So yes, meter per second, seconds can cancel. Anyway, there are two formula. In two way we can get simplified. So this L cancel away. Finally, m power 1, there is no power, we consider 1, length is not there, so L power 0, T power minus 2 and ampere inverse. This is one method. In another one method, instead of substituting this value, directly we can find it. See, B is equal to F by QV, no, F by QV. So for force, directly substitute the dimension, mlt power minus 2. And for charge, it is coulomb. Coulomb is a SI unit. And for velocity, it is meter per second. So LT power minus 1. LT power minus 1. Then finally, with respect to coulomb, because question la coulomb kuduthirukanga. Appo coulomb ku eta mari nam arrange pannom. Appadina enna varum? This cell cancel away. Then mass power 1, L power 0. T minus 1 become a numerator, plus 1, already one minus 2 is there, so minus 1 into this denominator coulomb become numerator, coulomb inverse. So with respect to coulomb, this is the dimensional formula of magnetic field strength. So in two ways, with respect to ampere and with respect to coulomb, we can write like this. Okay. So question la ungalku coulomb கேட்டதனால நாம இந்த மெத்தட் தான் போணும். பட் coulomb கேட்காம ampere கேட்டிருந்தாங்கன்னா நாம இந்த ஃபார்முலா யூஸ் பண்ணுவோம். Are you clear? I repeat once again. Find the dimensional formula of the magnetic field strength in mass, length, time and coulomb. அப்படினா நம்ம இந்த கேஸ் யூஸ் பண்ணுவோம். But instead of coulomb, if they given ampere na நம்ம இந்த formula யூஸ் பண்ணுவோம். So this is a given formula for the magnetic force. According to magnetic force, it is the product of, it is a vector quantity and it is the product of the magnetic field strength, charge and velocity. Therefore, magnetic field strength is the ratio between the magnetic force to charge and velocity. Substituting the dimensional formula. For force, the dimensional formula is mlt minus 2 because F is equal to ma, so we got this dimensions. And charge is the product of current and time, since current is the rate of flow of charge. Therefore, I is equal to Q by T or Q is equal to I into T. So instead of charge, I have written current into time. And velocity is the rate of change of displacement. So displacement by time. So this two time cancel. Finally, we have ma divided by time, current into displacement. Now substitute the dimensions. For mass, m. For acceleration, meter per second square. For current, it is ampere. For displacement, it is a meter, length. So length and length cancel. So L power 0. If there is no power, we consider it is 1. So m power 1, L power 0 and T power minus 2. Then ampere denominator you bring to numerator, it become a minus 1. So this is the formula, dimensional formula of magnetic field strength. Instead of coulomb, if they are mentioned here in ampere. But question எப்படி கேட்டிருக்காங்க, coulomb வச்சு கேட்டிருக்காங்க. If they ask in a question with the coulomb, then instead of using current into time, directly substitute coulomb. That's all. But anyhow, this both relation also correct. But this is for the case of coulomb, this is for the case of ampere. Okay.